Today I want to talk about how I use Claude Code to help me build my startup's infrastructure, and it saved me weeks. So first off, the startup. So the startup I'm currently working on is called Baseline IQ, and we develop a tool called Mayfly. Mayfly is a culvert designed tool, and if you don't know what a culvert is, they are pipes that run under roads to manage water flow, and they look like this. So the way it currently works is my co-founder, he is a practicing civil engineer, and so he does all the engineering methodology, and I'm in charge of all the software development. So let me show you the current state of the tool. It's currently deployed on AWS. And so the way the tool works is it opens up a map for you, and you're able to select location on the map. And once you select that location on the map, it gives you the lat and longitude here. So let's select one, and then you can run the analysis, and this takes a minute. So we're going to fast forward to this, but once it runs the analysis, we're going to get some results. So let's wait for this to run. Let's fast forward it. Okay, so it finished running, and what it does is it delineates the watershed at that particular point, and then it comes up with some values related to the watershed, like the area in the perimeter, the elevation, as well as the longest flow path. Now, the culvert design part, that is currently in development, but the important part here is the infrastructure is fully in place, which is what this video is all about. So let's jump in to how I use Claude Code to help me build out the infrastructure that this application is currently running on. Okay, so first off, we knew off the bat that we could not deploy this application on a simple hosting platform such as Vercel, because the application is a little more involved and Vercel just couldn't fully handle it. So the current state of the application is 3 services, a front-end service and 2 back-end services, and it uses some databases for data storage as well as for some async processing. So off the bat, we knew we needed to use one of the big cloud providers such as Google Cloud, Azure, or AWS. Now, we went with AWS because I'm most familiar with AWS. So going in, I knew that if we were going to deploy this into one of the major cloud providers, in this case AWS, we were going to need to build out a VPC for the networking, including the subnets, the NAT gateway, and the route tables. We needed somewhere to run the services. This could be either ECS or serverless. I had ruled out EKS Kubernetes because we just didn't need that sort of complexity for the state of our application. And then we knew we needed some CDN for protection, and the options in my mind were CloudFront or Cloudflare. And also, I knew that we needed this to be in Terraform, which is infrastructure as code. The reason for that is because we wanted it to be repeatable and we wanted it to be version controlled. But also, by having it in Terraform, it made it much easier to utilize Claude Code, because Claude Code could build out the Terraform code for us, as opposed to just giving us instructions on how to build it directly on the AWS console, which is a lot more error prone and would take much longer. So diving into Claude Code, what I did was I gave it access to our service repos and provided all the context. Then from there, we would get a plan. Now that plan is always redefined because it's going to give you an initial plan that you're probably not going to be fully satisfied with. So you can go back and forth and get to a state where you're happy with a plan, and then you execute and you review and correct. And you can do this cycle a few times until you get to a point where you're satisfied. Now, this is a multi-step process because at some point you might even deploy at a particular point. It might not be fully done, but that allows you to review what has been done so far, and then you can redefine the plan once again. So once that was all said and done, after a few cycles, we had some infrastructure and we had an application running in the cloud. And so what we got is a VPC with subnets, NAT gateway, and route tables. Now, this all came in the form of Terraform, and let me show you how that looks. So given that the network layer is common infrastructure for all the services that Mayfly uses, I knew we needed to place the Terraform in its own repository because it doesn't belong to any of the services necessarily. So all the VPC Terraform went into a repo called an infra repo, which holds that Terraform. Now, this was all produced by Claude Code, and I reviewed it, and it's quite involved. As you can see, we have the VPC code here, and if we go into the modules, which is the actual code that is called from here, as you can see, we call the module. We can see it's quite involved, but it's really just a pattern, right? So we define the VPC, and then we have the subnets and the route tables. And then also, if we go down, we can see the NAT gateway. And this was all code written by Claude Code. And while I could have definitely done this, the speed at which Claude Code writes this is much faster. So it sped up the development of the infrastructure by quite a bit. The next part was the load balancers, which in some cases, it is shared among all the infrastructure, and in other cases it could belong to just one service. So if it's shared among the infrastructure, we want that to be deployed in common infrastructure, which is that same repo. And if you come here, you can see there is a internal load balancer, which is for common infrastructure. And once again, it's a lot of Terraform code that's quite involved, which one can definitely write, but Claude Code does it much faster and speeds things up by quite a bit if it does it for you. So as long as you just check it, it does a very good job at it. And then there's also the option of a load balancer per service, which in our case, really only the front end one needs it. And if you come into a repo that I refer to as the Terraform ECS service repo, which is a module repo to build infrastructure with Terraform, you can see there's also a definition of a load balancer. And this would be used whenever a service needs its own load balancer. So it wouldn't be a load balancer shared among all the services. Now, that leads me right into the ECS module, which I just showed you. And the way that works is that each service needs to run an ECS. So instead of copying and pasting Terraform ECS code in each service repo, we can have a common module that each service can call upon to build the ECS infrastructure using Terraform. So that is the repo we were just on. And you can see here that this is the ECS defined, and this just defines an ECS task definition and the ECS service, which will be built for each service. In our case, the 3 services, right? So each one will build his own ECS service. And if we head over to the client repo, we can actually look at the Terraform and see that it has an ECS file and it calls on that ECS module. And using that, it will build the ECS using Terraform. And then one of the most important parts is how you get that from repo out to the cloud, and that is with a CI/CD pipeline. And for that, we use GitHub Actions with Docker, and that is also a common pattern. But if we come into the Basin IQ client, for example, and we take a look at the build and deploy, we can see that this is the CI/CD pipeline that's used. And what it does is it builds out a Docker image, pushes the Docker image so that the ECS service can use it. And if we go down to the Docker file, we can see the Docker file here. And you know, all this stuff follows a very common pattern, but it can take a very long time to write. So by utilizing Claude Code and obviously directing it in the right direction and correcting it as it builds, you can speed up the process by quite a bit. The last part was the Cloudflare. We decided on Cloudflare versus CloudFront, mainly because Cloudflare comes with a free tier and we wouldn't have to pay from the start. So this was more of just follow instructions. So I'm not going to go into details in this video, but maybe I'll make a future video where I talk specifically about how we're using Cloudflare for the CDN as a protection layer from things like DDoS. But anyways, so as you can see, The amount of infrastructure that we build out is quite large. A lot of infrastructure is code. It's not necessarily hard because you can definitely write this out and find tutorials online so you can copy and paste and accommodate to your particular use cases, because really they are just patterns of infrastructure as code that are commonly used across the industry. But by utilizing Claude Code, you can really cut down the time, because Claude Code can write this infrastructure as code very quickly. And as long as you have an idea of what you want to accomplish and you're able to direct Claude Code in the right direction and check what it's doing as it builds, you can really speed up your development process. This, for example, took me, I think, about a week, and if I would have done it all on my own, it would have taken a lot longer, because it's not hard, but it can be very tedious, and writing all this code out is very error prone. Claude Code is able to do it a lot faster and a lot more efficiently, and as long as you're validating, you can definitely reach a successful deployment much faster. So this video is not me telling you you can just grab Claude Code and say, hey, build out my app's infrastructure, and Claude Code will just go and do it. You still need to direct Claude Code in the right direction and validate everything is doing every step of the process. But if done correctly, you can definitely speed up the process of creating your infra by a significant amount. Anyways, that's the video about how I use Claude Code to help me build out my infrastructure for my startup, and it literally saved me weeks. If you find this interesting, let me know. We'd love to hear your thoughts. If you want to hear more about the startup and how we're building it, also let me know. Would love to hear your thoughts in the comments. But that's the video. I hope you enjoyed it, and if you like my content, you can find more over here, and I will catch you in the next one. Bye bye.